All right, so we are going to look at the 1.7 here in this video. It is called combination of functions and composite functions. So let's take a look at this. What are the objectives of this section? Well, it is to find the domain of a function, combine functions using algebra, and then form more functions by using what's called composition. Determine the domains for composite functions, and write functions as compositions. So let's start here and let's fill in some of the blanks. It says if a function f does not model data or verbal conditions, its domain is, and the missing word here is the largest. So the largest set of real numbers for which the value of f of x is a real number. So when you see a function, when it asks for the domain, you want to think, well, the domain is all real numbers. But there are some times when I need to exclude something from the domain. And what you want to exclude are numbers that cause division by 0. And real numbers that result in an even root, such as a square root of a negative number. So, for example, we're going to look at this problem. And this says find the domain of function g of x. And so again, you're going to start with the assumption that the domain here is all real numbers. But where I need to make an exclusion is when two things happen. So I'm going to start with this, all real numbers. And I'm going to ask myself, do I need to exclude anything? And the first question I ask myself, is the variable, or is x, in the denominator? And if x is in the denominator, what you're going to do is, if you answer yes, so I'm going to say if yes, then set the denominator equal to 0 and solve for x. This gives you the number or numbers to exclude. If you answer no, then you're going to move on to question 2. And you're going to ask yourself, is x under a radical, and I'm going to specify here, even root radical? And if you answer yes, then set the radicand. The radicand is the expression underneath the radical sign. So you're going to set the radicand greater than or equal to 0 and solve for x, or whatever variable is in there. And that will give you the domain. That gives you the values that can go in there. So this gives you the domain, where this one gives you the number to exclude. Now, could there be an x and in the denominator, and that in the denominator there's a radical, an even root radical? Yes. So you might have to do both of these. So let's try the problem that is located on this page. And it says we've got 5x over x squared minus 49. And we want to find the domain. So we're going to ask ourselves, is there an x in the denominator? Yes. So if the x is in the denominator, I'm going to set the denominator equal to 0. This is a quadratic. It is more difficult to solve quadratics, but in this case, this quadratic is missing the middle term, so I can solve this by isolating the x squared by adding 49 to both sides. And now that I get x squared is equal to 49, then now I can undo the square root by taking the, undo the squared term by taking the square root of both sides. And when I take the square root of both sides, I'll get x is equal to 7, but it's positive 7 and negative 7, because when you square 7, you get 49, and when you square negative 7, you get 49. So there's two possible values that equal 49. And so let's look at this. That means this is what we want to exclude. So this is my exclusion. So it's all real numbers except this. Now also, I will make sure that I'll answer no on question 2. And no, there is no radical sign here, no even root radical. So then I am going to say the only thing I need to exclude is 7 and negative 7. So let's draw this on a number line. So here's 7. Here's negative 7. So that means that I need to exclude this and exclude that. So I'm going to put open circles there. And then I'm going to highlight. I can have numbers that go this way. I can have numbers between negative 7, negative 7, and positive 7. And I can have numbers that are above. Now, you can use an open circle on a number line. You can use, some books will use, instead of an open circle, they'll do parentheses to exclude. So it looks like this. You can do either one. They mean the same thing. So now I have to write on here the different pieces, because there are 3 parts that are in my domain. We've got from negative infinity to negative 7. Remember, the number line that goes out this way goes to negative infinity. So this part here, written in interval notation, would look like this. Remember, what is interval notation? Interval notation is, it's not an ordered pair, but it's telling you the set of numbers between negative infinity to negative 7. So you can pick anything in that range. And so for interval notation, you use either a bracket or parenthesis. You put the smaller endpoint to the left, and you put the larger endpoint to the right. If you put them in the wrong order, it will be marked incorrect. Now, when do I choose to use a parenthesis, or when do I choose to use a bracket? You use a parenthesis for when you have an open endpoint. So an open endpoint means that that number is excluded from the set of numbers. You use the bracket when you are including. So that means it's a closed endpoint, or that that endpoint is included in the set of numbers. In this case, we are excluding negative 7, so we will say open endpoint and put the parenthesis. Next, we're going to say negative 7, it's the smaller endpoint, to 7. So to represent this set between -7 and 7, I'll write it like this. And then lastly, I'll put from 7, this goes out to positive infinity, this pink area here. So 7 to infinity. The last thing I need to do is say that it is all of this. You can choose from all of these. So I'm going to say union. So it's the union means the word and. These are all included. So this is the domain of function g written in interval notation. All right, so let's move on to the next one. And it says, find the domain of h of x. So here's h of x. Now, when I ask my first question, again, I'm going to assume all real numbers first, but I say, is x in the denominator? And the answer is no. So x is not in the denominator, so I can move on from that. I don't have to do anything. Is x under an even root radical? An even root radical means that the index is an even number, 2, 4, 6, 8, and so on. And in this case, the index number is not written here, but if it was written, it would be a little number here. And that is the index of the radical sign. This one has an index number of 2. Whenever you have a square root, they don't write the index, but it is known to be 2. And the answer is yes. So then I'm going to take the radicand. The radicand is just this part. This part has to be, when you put a value in for x, this has to be positive. You'll notice that if you take the square root of -4 on your calculator, you're going to get an unreal answer. It will say, it will error out. If you take the square root of -3, errors out. The value underneath the radical has to be a positive value. So that's why we're going to follow the instructions from the prior page, and we're going to say x plus 4, this has set it greater than or equal to 0, and solve for x. Here, to solve for x, what do I have to do? I'm going to get x by itself by subtracting 4. When you solve an inequality, is very similar to solving an equation. This is considered an inequality because of this symbol. The only difference from solving an inequality versus a equality with an equal sign is that if you were to multiply or divide both sides by a negative number, then this symbol would flip the other direction. But in this case, we're not multiplying or dividing, we are simply subtracting. So when we subtract 4 from both sides, we would get this. And so this gives us the domain. So this is the domain. So the domain is shown. So let's draw this on a number line. And the number line is not necessary. You don't have to draw this. I am doing it so that I can visualize what this looks like. It makes it easier for me to write the interval notation. So here's 0 and here's -4 on the number line. I'm just going to label this. Here's my number line. And I'm going to draw -4, and this is greater than or equal to, so the -4 is included. So again, you can choose to use a bracket or a solid dot at 4 and at -4. And then it's greater than or equal to, so that means it is everything to the right. When it's greater than, it's everything to the right. Greater than or equal to means it includes the endpoint of -4. So how would I write that? This is going to positive infinity. So I would say -4 is the smaller number, infinity is the larger number, and then I put a bracket here to say it includes the endpoint. So includes the endpoint of -4. So -4 to infinity is my answer, and that is the domain for this function h. Includes the endpoint.